Yes, hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company provide technological solutions across the world. Now in this video, in this bootcamp session, we are going to see how to recognize the handwritten images. Now see, in one of my bootcamp session, I have explained you how the numbers are recognized. I recommend you to watch my previous video. You will find that particular video in which I have explained you about how to read the numerical numbers. In that case, I have explained you that how, for example, let me show you that one more thing. Just a second. Here it is. Let me give you an example of that. In that video, I have shown you that how a person writes the numerical number. Like for example, let me zoom in. Here you can see a person can write 2 in this way also, because all the possible ways that a person can write, that means worst handwriting also can be recognized with the help of this, right? So I have prepared one session on that also. I have already delivered that session. You can see here all the different types of handwritings, they are included in this, right? Similarly, now in that video we have seen how to recognize that. Now in this video, in this session, we are going to see how to recognize the handwritten alphabets. Now you might be thinking, what is the use of this? Now the use of this is that, for example, previously when there were no computers, everything was done in the handwritten form, right? Now slowly all those documents needs to be digitized. In government sector also, there are some companies, those they take the projects from government and they assure them that we convert all your handwritten documents into digital format. So same thing is done there also. What they do, they just scan the paper. In one of my project, I have seen that the company has taken the contract from the government and they provide them all the handwritten documents. And those handwritten documents, it can be anything, like you can say the handwritten script or the handwritten books, anything. So they just scan those document, and whatever the scanned document, inside that whatever the alphabets, they are converted into digital format. So that is the use, and this is largely used because it gives you the facility that instead of having 1000 books, it is better to have 1000 PDF files on the net so that anyone can access, right? So that is why, that is the power of digitization. And in upcoming days and upcoming future, that is largely required, because every company or the every government sector, they need digitization. So that is why this is what we are going to see in PyTorch. PyTorch has the capability in CNN, Convolutional Neural Network, right? So in this there is a capability of reading the handwritten documents. Now here you will see how to image, how does image recognition works, right? It does it using a convolutional neural network. Now see, once you provide a image of any alphabet, for example, a person has written A here, right? Now he never know that why in future it will be used to recognize. He has written in his own handwriting A, alphabet A. Now this alphabet A in the format of 32 by pixel by 32, it's a very small image. Now this A image is given to the machine. Now this machine uses different layers, right? Convolutional, subsampling again, then full connectivity neurals, and with the help of this, after all, it gives you the output that it is written A. For example, if you take this, normally nobody writes A like this. Normally we write the A in our standard format, right? Suppose if someone has written A, now it will, this is 128 by pixel by 128. Now you can see here what is the convolutional, how CNN works. Here is image recognition is we are doing, right? Now with the help of CNN, now you will see here, this is a convolutional layer. With the help of, there are two layers more, ReLU function, the pooling function again, right? So convolutional 1, ReLU function, pooling function. Again convolutional 2, the same function is repeated again, ReLU function and pooling function, right? Then the third is, again after all these repetition, you will see fully connected layer. There is one more layer, fully connected layer. Fully connected layer means, I will explain you like this. Here you will see this fully connected layer, as I have given you the example of interview process, right? In the previous sessions I have already given you the example. Let me repeat again. Interview process means exactly what? I have asked questions to all the 10 candidates. Now based on that, I will again ask the next question. The next filtering process will be based on the previous that they have provided. Okay, now I will put some complex questions, that whether they are capable enough to analyze the questions. Then this is called fully connected. That means my next filter is fully connected with the previous filter. Then once they are not capable, though I will filter out those who are capable in analyzing the question, exactly what type of complexity is there in the question. Next layer is the way they are replying the answer, or their attitude towards their job or the vacancy they are looking for. So this is called asking the questions which are based on the previous layer. Same thing is here. In this it is internal connectivity, right? So these are the layers, fully connected layers. Now let's come to the first slide here again. Now see here, let me make this bigger. Okay, yes, now this is called fully connected layer. So basically there are 4 types of connection layers. One is layer in convolutional. CNN consists of 4 layers. One is convolutional layer. Now this convolutional layer means, here it takes a small part of that particular pixel. Then ReLU function is an activation function, we will see it later. Then the pooling function and fully connected function. Now let's see convolutional function, right? So if you see here, the convolutional layer is used to extract feature from the input image, right? This is the input, this is the kernel, and here you have taken, for example, 1 multiplied by 1, 0 multiplied by 0, 0 multiplied by 1, and it will take the whole as plus. So in this way, that means pixel is made in small size, right? For example, if there is a image of bigger size, and if you want to make it small, what you will do, you will keep everything, you will make everything in small size. For example, a big image of a house is given to you. Now that's house, if you are asked to make it small, so what you will do, you will make everything small, that house. For example, the television size you will make very small, tiny, and only one dot you will denote it with only one small box. Then the person sitting in front of the television, you will denote it with a very small image, right? So same thing is done here. Now next is ReLU function. It is an activation function that introduces non-linearity, right? Sets all negative pixel to 0. It will not keep negative pixel as negative, it will make it 0, introduce non-linearity, and output is rectified feature map. We will see it in depth in few minutes. Third is pooling layer. Now pooling layer means same. Pooling is of 2 types. For as I have just given you an example of the house, internal house image, what you will do, you will make very small things. If you are asked to minimize this picture in a small image, thumbnail image, so same thing is here. You will see here max pooling. Now 30 is the maximum number, 30 is here. 20 is the maximum number, 20 is here. 112 is the maximum number, that is here, and 37 is the maximum number. Average pooling means 30 plus 2, that is 32 divided by 4. 4 8s are 32, 8. 12 12 24, 24 plus 20 44, 44 plus 8 52. Now 52 divided by 4, so that is 13. Similarly here you will see this is the average. Now that means, look at this, pooling layer is used to reduce the size of any image while maintaining the most important features. Now most important features, for example, let me give you a very simple example. A person is standing, there is an image of a person standing, and he wore a blue shirt and blue pant, right? And that person is average, height is average. Now if you minimize that image, you will just put a small blue dot, because the maximum color, that is blue, right? So similarly, if that person, like 1000 pixel by 1000 pixel is given to you, and if you are asked to make that image as 28 by 28, so what you will do, you will just put a small blue line, that's it, right? So that is called minimizing the image, right, with the help of pooling. Then you will see here fully connected layer. Again, the fully connected, I have explained you when I if 10 candidates are given to me, I will ask all the, and every question is connected with the back question, right? So this is the real life example I am giving you for understanding. But is in this internal, the fully connected layer in a convolutional network connects every neuron in one layer to every neuron in the next layer, right? So that is called fully connected. And finally it recognizes it as a bird. Clear? Now let's now it's the time to see how practical, and the daily life scenario is that the same that I have given you. There are two types of daily life scenario. In one, the images are used, but the maximum which is practical daily life example is used, that is digitizing the handwritten documents. Suppose you are having suppose there are some novels written by great writers, and the company now wants to make it as PDF file. Just hold on a second. The company that wants to make it as, yeah, the company that wants to make it as PDF file. Now in that case what happens? In that case what happens? The company will scan the image, put that image in this, and it will just detect the alphabets, and then it will now make it as PDF, right? So let's go to some practical part. Now here I have already prepared one script, and now just I will do it. Here you will see I will prepare a new IPython file, interactive Python notebook, right? Now interactive Python notebook, you will see here handwritten. I will rename it as handwritten document. You will see handwritten document. Just give me a second. Okay, yes, now I have created this handwritten document, and now I will open this document. Now first of all, what we need to do, we need to pull all the necessary libraries. Here you will see import libraries, step 1, that is torch. This is neural network, right? This is optimization. Then the data sets, then data loader, then the matplotlib for plotting the data, and numpy for calculation, and PIL for images. PIL for images means we are having one folder, inside that all the handwritten images are there, which are possibly, right? So that the person having good handwriting to worse handwriting, we are able to recognize all those. So for training purpose, we pull all those alphabetical images, right? Now our next step is, if you go now, you see here step 2, set up a database using image folder. Now we are already having an image folder. Look at this. If I go this here, image here, right, testing image, there are lots of all the A to Z images are there, right. So these images are containing, they are containing the alphabets, sample alphabets, and they are grayscale alphabets, and the size is 28 by 28, any size, but we will resize it to 32 by 32, and then we will convert it to tensor. That is the idea behind this. First of all, we will pull all the images, then we will convert, take one by one images, and then we will convert it into, first resize them, and then we will convert it into tensor, right. So far it is clear, right. Now train data set, we have to create a train data set. Your root directory is data directory, data dir train. Look at this, this data dir train, data dir test, data dir test. Here is, so train data set, train loader, train test data set, test loader. These two things we need to have, and then class name is, we have to put the class. Now if I enter this, now see what happens here. We have created the classes up to A to Z, right. Now in this A to Z classes, what we need to do, we have trained, we have created the function, that is train and test. Now let me show you this. Now see here, CNN, define the CNN architecture. Now here the CNN architecture, as I have shown you, convolutional 1, convolutional 2, right. It takes the images and then fully connected 1, fully connected 2, that is, I have explained to you the fully connected layer. It was all about the layer. And then maximum pooling. Maximum pooling is used here, not average pooling. And then we have applied the ReLU function. It converts all negative to -1. Now forward, we will forward it, and then let's see return X. Here you will see this is the all the calculation that is done behind this. After that, you will see here initialize model. Now see here, initialize model, loss function and optimizer. Now CUD, it is for CPU and GPU, we already discussed, right. So it is an optimizer model. Device torch.device CUDA if torch dot, that means if it is running on any device, that is all about that, right. Now train model function, this is our main task. We are training the model now. Now what we are doing, we are training the model, and for this we have to define the epochs. Epochs means repetition. It's just a repetition. For example, if you will see here, the dust cleaning robots are already launched in the market. So that dust cleaning robot, when we buy that robot, what it will do, it will first move into the whole room and it will just point out the corners of the room, right, the corners of the room, so that it will train itself. Initial 3-4 times it will make mistake, but ultimately it will train itself enough that it knows, that robot knows that where is the corner and at this point where that robot is standing, right. So this is called training system. In competitive exam also you can see there is one more example. Competitive exam, a boy appears in competitive exam. In first exam he will get an idea what type of questions are asked. In second competitive exam he gets an idea, okay, now what type of question. So he will get an idea of the pattern, that how the questions are asked, right. Same thing is taught in the coaching classes of the competitive exam. Same thing is here, the machine also does the same thing. It trains itself by the repetition. So that is called, that is what we call it as epochs. It runs several number of times. Here we are taking only 6 repetitions. Now here you will see again epochs in range, model, train. Okay, this is the model. Then zero gradient, then the criteria is given, outputs and labels. Now if I run this, now it will start running the epochs. So now it is training itself. Now you can see here loss is only 3%, 2%, next time it is less than 2, next time again it is less than 1. Loss means the difference between the predicted and the actual, right? Now see, 6 time it becomes lesser and lesser every time, right? After that you have to evaluate the model. Now evaluation means accuracy. You will find the accuracy of the model. Now model evaluation, evolve, right? So torch, this is called accuracy. It will print the accuracy of that model. So it will automatically give you the accuracy is 98%. That means whatever type of alphabet you give him. For example, if I give A like this, that is also, it will also recognize. I will give A like this, and if I give A something like this, then also it will recognize, and if I give A like this, it will also recognize. So that is 98% this model is accurate. Okay. Now what I am going to do here, function to predict the new image. Now new image function is, we are creating a function that will predict a new image. Now here we have given image of L, we have just given the path, right? Convert L. Now what you will see here, compose, this is the function, prediction function, it is written here, it is standard function, right? You don't need to do anything in it. Now here you will see, if I show you, this is called prediction function, and now the same function we are going to plot. Now definition, plot prediction, right? So whatever the predicted image is there, it is sent here, and then based on that it will plot the image. Now if I hit the enter, you will see here predicted F, but the original image was this. Similarly predicted H, the original image was H here. Predicted Q, the original is Q here. That means why it is 95%, that is why it has shown here 98% capable, 98% accurate. The reason is the same. The 98% accuracy shows here like this. Okay, so let's have a quick recap also. So you can go here again. Now see here, just a second. Okay, first of all, now I recommend you to watch this again video, right? First of all, whatever we provide, see nowadays the same. Now let's see the applications of this particular script. Applications are, for example, if you want to digitize several handwritten books, it can be done. Several printed, but in olden days it was printed by machine, and that machine fonts, they are not, for example, you are having some typewriter pages, right? Page typed on a machine, mechanical machine typewriter. So the fonts are not aligned properly. So in that case, those type of books, typed books, they can be converted into PDF files. Then some handwritten books, we have already discussed handwritten. Then some scanned pages which needs to be digitized, that is the third application. Then some purchase orders. Now in business scenario, let's see business scenario, some purchase orders are there, right? There are some handwritten purchase orders. Now those purchase orders can be scanned, but we need to take care that they should be in appropriate handwriting. Otherwise, if the handwritten documents, if there are lots of changes, they should be in proper format, right? Then there are so many handwritten sales orders also. So we have to first feed all these documents in the format of image, and with the help of image we have to first test on one or two sales orders, and once it is okay, then it will be converted into the digitized format. In the digitized format, it is best suited for handwritten documents, right, as well as the photocopy, the Xerox copy documents. In what we say, the purchase order, the sales orders, we need to take care the format should be same, equal, then only we would be able to scan those. And for this purpose we need the four types of different layers: convolutional layer, relief layer, the pooling layer, and the fully connected layer. Now why these fully connected four layers are? These four layers are inspired by the our daily life process only, as I have given you the example of interview process. Then you can see here, this is the convolutional layer. Second is relief layer. It converts all the negative values into the 0, right? After that you will see the pooling layer. Pooling layer means it is used to make the images as small as possible, right? After that you will see here the fully connected layer. Fully connected means every layer is connected with the previous, right? I will ask the questions based on the previous level of their understanding. Otherwise, if I ask out of syllabus question, the candidate will not be able to reply. So that is why this is fully connected, means every layer should be connected with the previous. Now let's have a quick recap also. Let me show you that. First of all, we have imported the torch, all the necessary libraries. Then we pull the data, then we resize the image, then again we convert it into tensor. Tensor is just a matrix. I have already explained you in my previous videos. Please have a look on that. Then we will load the data set. Load the data set. Two types of data sets are there: train data set, test data set. Train data set for images, right, and test data set also for images. Now these are the images of alphabets A to Z, right? Then check the class name. First of all, we have created the classes up to A to Z. Then CNN architecture provides you the facility of convolutional network, and then we provide the linear. We apply the formula of linear and max pool function. Then what we will do here is relief function, right? After that, initialize the model loss function. This CUDA is used. Normally it is used if your function is running on any device or what, right? Then train model. This is most important. Train model means training the model itself. It is training itself. Now it will train the model, and then after that, after running, you will see here training. Initially the loss was 3.3%, then 2, then less than 1. So after that we will evaluate the accuracy and consistency. So evaluate model, that is eval model eval, and with the help of that we will evaluate it, and the accuracy comes in 98%. That means this is 98% accurate. After that we will see here, we will put a new image to understand whether now we are testing it, that whether it is able to understand. You can put if you want, you can write down any alphabet on the paper, capture that image, make it small, very small, and then just save that into the folder, and then you can put the path of that folder, and then see it will work. After that, plot data, plot prediction. We have to plot the prediction, right? So after plotting this image into this format, so now see here, predicted image is F. We have whatever we have given, it has predicted accurately. Actually these images are very small images that we provided, and then it has predicted the correct image, right? So you can test it by your own handwritten image also, and if any error comes, you can put it into the chat box, comment box. I will resolve them, right? So guys, this was all about the alphabet recognition, and my previous video was on numerical recognition. So I recommend you to watch both and then correlate both videos with each other, and then try your own script, right? And if you face any issue in that, then you can put it into the comment box. I will be happy to resolve your queries, right? So guys, today we will conclude here, and in our next part we will see some other functions, some other important functions, right? And those who are new in this channel, please like and subscribe the channel, and you will get the notification of the latest upcoming webinars and boot camps, right? So guys, thanks for attending the bootcamp session. Thank you, and practice this, right?